Good morning, Norrköping. Today I'll be talking about scaling WordPress with Amazon Cloud. But first, who am I and what I am doing? My name is Miljenko Rebernišek and I live and work in Belgrade, which is capital of Serbia. I have built my first website at the age of 13 years, and from that point I have built a lot of web application, mobile application, and do some desktop development also. Today, I am working as a software engineer for company Devana Technologies, which is behind one great product, Managed WP. What I do daily? Well, I develop things with WordPress, Symfony, Doctrine Stack. I also build infrastructure things with Amazon Cloud, configuration management tools like Ansible. I also do some DB stuff with MySQL, MongoDB, and things like that. Why I'm here today? Well, I have something to share with you, but first I need to ask you one question. What will happen with your site while you are on your vacation and enjoying it? Will your phone ring from angry client who just launched some viral Facebook campaign and site just broke? Well, this is me during my vacation just a few days ago in Greece, and my phone didn't ring. I just saw scaling logs, and that was everything. What I'm covering today? Well, Amazon components, separating data layer, horizontal scaling, code deployment, and this will be architectural overview and not step-by-step tutorial. Well, Amazon have a lot of components. This is just few of them that we'll be using, and I'll tell something about them. The first component is Virtual Private Cloud, or VPC. Virtual Private Cloud is partly isolated part of Amazon Cloud, your own private network, with your own IP ranges, subnets, your own routing table. You have complete configuration control over this network. We'll be using this for security reason. The next thing is Elastic Compute Cloud. This is actually resizing compute unit with real physical CPU, memory, and disk unit. This is the place where the whole code is executed. Well, there is a lot of instance types that you can use, and I'll tell you something about that later. This instance can have two kinds of storage, persistent storage and also non-persistent storage. Persistent storage utilizes something with name Elastic Block Storage, which is actually a network disk with abstraction that you mount and boot your system from this point. Underneath is SSD disk, and there is two varieties of this disk. The first one is general purpose, which is okay for, let's say, normal application. And we have provisioned I/O disk for demanding read-write application. And these provisioned IOPS are guaranteed. And also we have non-persistent disk. The all content and all data at this disk will be lost during reboots and termination of this instance. The next component that we'll be using is Elastic IP. Elastic IP is actually a static IP, just we designed for cloud system. What it do? Well, you can quickly remap this IP from one instance to another instance, so you can mask failure of one service, one instance. This IP is tied to your account and not to any specific instance. The next thing that we'll be using is elastic load balancing, or ELB. What this service do is automatically route traffic, incoming traffic, to all of your background instance. Routing can be done on two layers, layer 4 or layer 7. Layer 4 is doing just plain TCP balancing, and layer 7 is doing HTTP and HTTPS balancing. ELB have one nice feature, and that feature is health checking of background instance. So only health instance will receive traffic. One great feature also is SSL offloading. So you reduce your CPU usage of your instance. ELB automatically scale, but there is one thing that you need to know about this. If you have large spikes in traffic, for example, from 100 visitor to 20,000 visitor, well, Amazon suggests to contact them to pre-warm your ELB in order to be able to receive this traffic. In other variant, it automatically scales up and down without your need. It's also fully operational monitoring. So you will have a complete status, for example, from backend latency, 400, 500 status codes, and things like that. The next component is Route 53. Route 53 is actually domain name system designed for cloud. It's scalable also. It can serve like DNS system for your private VPC, and also support health checking of your background instance. It can also do some cool stuff like routing your traffic, and there is a few types of routing: latency-based routing, geographic targeting, weighted round-robin, failover also, and simple, straightforward routing. CloudFront is next component. This component is actually CDN, or Content Delivery Network. What this does, it's, well, there is a lot of edge servers everywhere in the world, and these servers are connected with dedicated short path links that are fully monitored. So your data does not travel across public network with variety of routing. It does support dynamic content. It supports variety of HTTP requests like pod boost, and also supports geographic targeting. The next component that we'll be using is auto-scaling, and in that context we'll be using auto-scaling group and launch configuration. Auto-scaling allows you automatically to increase number of your backend instance in case if you have traffic spikes, and in case of ours, this instance will be automatically terminated. One nice feature is also health monitoring of your instance, so unhealthy instance will not receive traffic and will be replaced also. Launch configuration just describes what will be launched. The next component that we'll be using is Simple Storage Service, or S3 service. This service is scalable and durable object storage. You have unlimited storage per bucket. Bucket is something like, I'd like to say, folder. Every file stored on S3 is cross-region replicated, so it's fully fault tolerant. It does support versioning of your files, so you can have multiple versions of single file. it does support data lifecycle. For example, you can configure to after 30 days your file be archived or deleted depending on your need. The next component that we'll be using is Elastic Cache. Elastic Cache is a memory-based system with support for two engines, Memcached and Redis. It's fully managed. It supports multi-zone replication. And it have automatic failover. Also, it does support backupping and restoring of your data, basically point in time. Also, like every service here, it does support detailed monitoring, so you can see how much you have get requests, how you have set requests, so you can further monitor that and plan your development. The last component in this section is Relation Database Service. A Relation Database Service is a database management system in cloud. It's completely scalable and it does support failover. What RDS do? Well, it supports automatic patching of your instance upgrading, so you don't need to do that manually, and you don't need to worry about that. It does support automatic backups also, which is one nice feature. I think in this moment that you can store up to 35 daily backups of your data, and you can restore any point in time with these backups. Currently, there is support for few engines. The first one is Aurora, which is MySQL implementation, version 5.6, but just Amazon implementation. Then there is standard MySQL, Postgres, Oracle, and of course, SQL Server. The next chapter will be data separation. Well, why we need to separate our data? We want to ensure capacity for further growth. We want to speed up our performance, and we want to prepare us for horizontal scaling. And we also want to make our data highly available. What we'll be doing here? Well, we'll be using CloudFront as CDN the provider. CloudFront does support caching rules based on URL or standard HTTP headers. CloudFront and S3 have great implementation and synchronization, so we'll be hosting our files on static files on S3. All our dynamic content will be served from EC2 instance, but with caching headers, and CloudFront will utilize browser caching also. This will reduce our backend hits and will also optimize delivery time to user. It will be lower the latency. What will we do? Well, we'll be using Route 53 for our DNS management, CloudFront for distribution, and CloudFront will serve our traffic static file from S3 bucket and dynamic content from our EC2 instance. But first, we need to put our files on S3. Like you know, WordPress does not support any cloud natively, so we will need to use some plugin for that. Two plugins that can upload media files and static file to S3 are W3 Total Cache and WP Offload S3. The first one plugin is free to do and support exporting of your existing files. And the second also support this, but it's paid feature to export your existing file. This plugin will upload your data to S3 and replace URL in database. Also, you can do this via system level, and you can use S3FS VFUs, which actually mount S3 bucket as your local disk. If you're using this, it will be not that fast like local system, because in background it's doing HTTP request, but does not require that much synchronization in your WordPress database, and does not require URL replacement. Also, we'll move our database from single instance to our hosted database or RDS service, and we can use Aurora or MySQL engine. Our configuration will be master slave with multi-zone availability setup. What we can do here, we can send all our read requests to our slaves, which are read only, so we can optimize scaling of our database, and we will send just writes to our master database. WordPress does not support this automatically, but there is one nice plugin, HyperDB, which is drop-in replacement for WP DB. How much I know, HyperDB is developed by WordPress.com, and they are using that for their commercial product. HyperDB also support failover on application level, and it have some also nice feature. Also, RDS will give us automatic failover in case of downtime of our master node. Also, we want to reduce hits to our database, and in that case, we'll be using object cache that WordPress provides to us. By default, these objects are not stored anywhere, so we'll be need to use some external plugin for this. Again, we can use W3 total cache, or we can use memcached object cache. In this case, we'll be using memcached, but there is also plugins that support Redis if you prefer that. So finally, this will be our schema for data separation layer. We'll be using Route 53, again, for our DNS management, CloudFront for content delivery with statics file from S3 bucket, and we'll be route our dynamic content to our web server. This server will be connected to Elastic Cache node in one and another region with MySQL master and automatic replication to our slave in another region. In this way, we made our data highly available, and we prepare that data for horizontal scaling. Well, for horizontal scaling, we'll be using automatic scaling, which is free service of Amazon. And the first thing that will route our traffic is ELB. We will configure ELB to do our health checking of our background instances. And what we need to create also is launch configurations and alarms that will trigger these scaling events. A launch configuration describe what will you launch. It describes instance types, storage type, network configuration, security groups, and things like that. Alarms are various metrics with given threshold. Metrics, there is a variety of these metrics, and Amazon give you a few hundred metrics for all their services that they support. For example, sample metrics can be CPU utilization, network in or out, memory usage, disk I/O throughputs, and all sorts of these things. For many cases, CPU usage will be the most sufficient metric that you can use and alarm that you can configure, but it really depends on your site. Autoscaling group defines large configuration that you will be using, but also describe how many instances do you want to have. It describes your minimum, desired, and maximum capacity. Also, this autoscaling group define timing when this will be happen. How much do you want to have, like for example, cooldown time from last activity, and also define which alarm triggers will trigger this scaling. How autoscaling group work? Well, when you have a spike, for example, autoscaling group will launch new instance. And after this instance pass all health checking, it will be added to ELB and it will be start routing traffic to this instance. Be aware, autoscaling group will not launch more than maximum capacity, so keep eye on this number and always put it little higher than you expect. Also, after rush hour pass, this autoscaling group will remove one by one instance until desired capacity is met, and everything this scaling is done by alarm triggers that you have defined, and in this case is CPU utilization. Be aware, any data written to this server will be destroyed during these scaling events. In that case, we need to make our WordPress to be stateless. In previous chapter, we have covered user-generated files, but third-party plugins can use file system, and I cannot give you the right recipe what you need to do this, because it's really different from plugin to plugin, but be aware of this. Fortunately, WordPress does not use any session storage of PHP. It's using cookies with query against database to authenticate user. But third-party plugins can also use session, which will probably be misbehave, but beware of this. Our final schema will look something like that. Route 53 for DNS management, CloudFront for content distribution, ELB for routing our inbound traffic to our instance, and checking health of our instance. We'll have now servers in 2 availability zone, and in each availability zone, this instance will automatically scaled based on alarms which we defined. Also, static files will be hosted on S3 bucket. How we need to do now code deployment, and once again, you cannot write anything to this instance. Anything during these scaling events will be destroyed and will not be shared among servers. What this means is that you can do any plugin theme install, you can do any upgrades of this plugin and themes. Everything needs to be done on one place and then deployed somewhere else. I will cover 2 types of deployment. The first one is by pre-baking your Amazon machine images. This is done by using one gold instance, and you make all your change on this instance. And after you make your change, you create a new snapshot of this instance. You update to actually create a new launch configuration and update your existing auto-scaling group. What you need to do next is somehow deploying these changes. You can do this manually by terminating one by one instance, or you can use some tool for that. One tool is AWS AJ Release Tool. or you can use some configuration management tools like Ansible or any other similar tool. What this tool do? Well, they increase maximum capacity for one and launch new instance with new launch configuration. After this instance pass all health check, they will terminate one old instance and launch new, and this will be repeated until all instances are replaced. After this happens, maximum capacity will be returned to original value. This also, like you see, can be really, really slow, but have one big benefit. You can do system upgrades during these deployments. This is not something for, let's say, a few daily changes. So we have another deployment method for that. We can use AWS Code Deploy, which is a file and command line deployment tool. It does support auto-scaling group, so you can target only one scaling group. It does support rolling updates, which will give you benefit of, for example, sending your deployment to 30% of your instance. You can monitor this deployment, and you can stop it and roll back in case you see something wrong. You have also deployment history. Code Deploy integrate with Git or S3 for as source. For example, if you're using S3, you will just give path to S3, which is zip version of your code. During this change, only code is changed, but it's much faster way. So what's next after we have covered this? Well, instance types. There's a variety kind of this instance, and by my personal experience, T2 instances are just for deployment, testing, and staging. M3 and M4 instances are for some small projects. C3 and C4 instances are actually for production because they are much more CPU powerful. And R3 instances are for database and caching layer. Like you saw here, there is a lot of step and a lot of configuration that you need to write and make. So you will probably like to automate these things. I will just mention a few of these tools, and I will not go in deep with these tools because it's another topic. You can use Amazon Beanstalk, CloudFormation, Cloud Deploy, configuration management tools like Ansible, Chef, Puppet, or you can build your own in-house tools because Amazon supports everything through API. Monitoring. You will like to monitor all of your things. Amazon provides hundreds and hundreds of these metrics. Pick one that's fit best for you and keep eye on this metric. You can use also some external tool for big screen display in your office, and my current favorite is Librato, which can aggregate all of these metrics. And the last thing is cost. Well, using Amazon Cloud can be really costly because there is sometimes hidden fee that you don't look at first. For example, like request counts, network traffics, and things like that. But you can reduce this cost by using reserved instance, and you can say from, I don't know, 10 to up to 50% on this service, depending on how much you commit, for example, for all upfront, 1 year, 3 years, and things like that. And always enable billing alarms. These alarms will inform you if you have, I don't know, something wrong set up, so you will know with this. So this was my first WordCamp presentation, and thank you for your attention. And questions are welcome.
Thank you. If you have any questions, please pass the mic, or I will try to run around and pass it on. It will be easier to hear, and also it will help for the recording. Any questions? Yep.
All right. I'm curious, how do you transfer the MySQL data from a local MySQL or dedicated MySQL server to RDS?
Because RDS is MySQL compatible, you can just use MySQL CLI console, so you can load your file export.
Okay.
You do MySQL dump from your existing local and just load it to RDS.
Cool.
Thanks.
Any more questions?
The Amazon's MySQL replacement, I can't remember, is it Aurora, is that what it's called?
Yes,
Yeah.
Aurora.
Is this something that you've used yourself with WordPress? I've seen just recently in an article that it's supposed to be very much faster.
Yes, Aurora is actually a new service, new engine that went out of beta, I think, last month. So it's pretty much faster. It's Amazon implementation of MySQL engine. So they have tuned various things for their infrastructure. So it will be much faster. My tests also provide that this is faster, and they are compatible with 5.6 MySQL version.
Thanks.
Yeah.
Anyone else?
Also, feedbacks are welcome. You can send me by email or you can contact me here.
Well, thank you for your presentation, and we have a few minutes until the next presentation at 10 o'clock, like in 5 minutes. So thank you.
Thank you.